Rearrangement in organic synthesis is an important area to understand. Today we will try to focus on some molecules which involve rearrangement system. These molecules present a difficult situation for beginners because it is quite confusing to point out what is happening in the molecule or how it has formed. So when we perform retrosynthetic analysis, usually we move in backward direction. We focus on a material and then subject it into retrosynthetic analysis for getting uh, its precursor. So we will focus on these molecules and point out which rearrangement is taking place for making such molecule. So let's first focus on some molecules which are difficult at first instance, but once we understand the rearrangement phenomena, then we can easily subject those molecules to retrosynthetic analysis. I am sketching these molecules on the screen. Seven-member ketone, tertiary alkyl ketone, and one last example, so these are different systems which are difficult at first instance because this involve rearrangement phenomena. So before subjecting this molecule to retrosynthetic analysis, let's first focus on different rearrangement reaction and mechanism, because without understanding those mechanisms, it is quite difficult to subject this molecule to retrosynthetic analysis. So the first is ardent acetate reaction. Basically, ardent acetate were two German chemists who propounded this mechanism of reaction which involve the conversion of carboxylic acid to its homolog, or it's another word, it is homologation reaction. For example, we transform carboxylic acid into its another homolog by adding a methylene group. So how this reaction take place? Usually we call it homologation because the next higher homolog of the starting material has obtained. Usually this method is popular for producing beta amino acid from alpha amino acid. Again, beta amino acid is next homolog of alpha amino acid, so that's why this reaction was at the beginning introduced or used for these particular purposes. So what happened in ordinate ester reaction? Usually the mechanism involves a simple step. First, the carboxylic acid is treated with thionyl chloride. We get acid chloride. This is reacted with the diazomethane for getting alpha diazoketone. This is alpha diazoketone, which is subjected either to heat or photocatalyzed. Or we can use a catalyst of silver oxide for getting a carbene-like species. Here we have one hydrogen, and this is subjected to a metal catalyzed Wolf rearrangement. In which we obtained species like this, which is electrophilic in character known as ketene. This is electrophilic in character, which capture a solvent that is nucleophilic in character, such as water or alcohol, for giving esters. And at the end, this ketene capture either water or methanol, with water we get next homolog of acid, and with ethanol CH3OH we will get ester. So this is all about ordinate ester reaction, which is very important before we understand a system, because this reaction involves the introduction of a methylene group. So let's focus this reaction on the first example we have. If I break, this is an extra group. If I break the molecule, or first subject it to functional group interconversion, OH, and now break it, which is 1, 4. I am numbering it 1, 2, 3, and 4. So this disconnection is known as 1,4 disconnection. I can show it on the arrow. 1,4 disconnection. So I will get a species like so this skin tone is unnatural in character because we cannot have material like this, so this connection is not feasible. In order to get a more feasible disconnection, we will have to remind ordinate extrovert reaction. While keeping this in mind, we can disconnect the molecule in another way. By reducing this methylene group, which can be introduced by ordinate extrovert reaction, so that I could make my system simple. So this is carbon number 1, 2, 3, and now I am subjecting the molecule to functional group interconversion. Here I can bring OH group, and now I break right over here, which is 1,3. Earlier I made a 1,4 disconnection, which generated material that was not available. So one thing that is very important in retrosynthetic analysis, that we should reduce or disconnect a molecule to those syntones which can generate reagents that are readily available. So in 1,3 disconnection, we can get the syntone that are available. So how we can simplify the system with the help of ordinate extrovert reaction. So here we applied this reaction for simplifying our retrosynthetic analysis. Now check out it simple synthesis, so that we could understand what exactly happened during the reaction. This is carboxylic acid. Here this species can further reduce to carboxylic acid. It is treated with phosphorus Br2 in the first phase, and in the second stage we subjected it to methanol for esterification. So we get a species like alpha bromo ester. So this alpha bromo ester is subjected to reformatic reaction by reacting it with the zinc, and then we react with cyclopentanone, and we will get species number 1, let me call it 1, which is alpha-hydroxyester. So I will obtain it right over here as a result of reformatic reaction. For methanol I can get Me over here. For ethanol I can get, so I use methanol, so therefore I am using it OH, which is further subjected to hydrolysis. And then with thionyl chloride in pyridine, whenever we use thionyl chloride, so we will use pyridine as a solvent, therefore we will get a system like. Now we will use the application of diazomethane in the first phase, because we are doing an Ordinance asteroid reaction. CH2 and 2 diazomethane, and then subjected it to photo catalyst. Therefore we will get the target material. This is target material. So we can obtain this molecule with the help of Ordinance asteroid reaction. Here what is important in this reaction is the methylene group. For example, if we do not have Ordinance asteroid rearrangement in our mind, so we cannot subject this starting our target molecule to a successful retrosynthetic analysis. So therefore we should have opinion about all such molecule in which we have an extra methylene group. So therefore we should have Ordinance asteroid reaction in our mind, so that we could apply it for simplifying our system, whatever we have simplified on the screen. Next we are going to put the another molecule which we have a 7-member ring ketone. Again, the system look a bit difficult to interpret or subject for retrosynthetic analysis, but here we need to understand the application of diazoalkane and ketone. Diazoalkanes and ketone, which are very important for ring expansion. Usually a 6-member ring is converted into 7. So diazoalkanes and ketone can be used for ring expansion. For example, we have a system like, and we want to react it with diazoacetic esters, which we have studied earlier. We subject it into basic condition and we get a system like this rearrangement takes place and we get the target material. So with the help of cyclic ketone and diazotic ester, for example, this is which introduce a methylene group into the system, and we can get the target material. For example, if we have a 5-member ring, so we can expand it into a 6-member ring system, much like this. So we can use the application of diazoalkane such as diazoacetic esters for ring expansion. So this reaction involves a ring expansion. As far as the another example is concerned, usually we should have pinnacle rearrangement in mind, because this molecule let me clarify it. Which is symmetrical diol, and it can be used as a starting material for a tertiary ketone. So whenever we look at a tertiary ketone, therefore we should have an idea of pinnacle rearrangement in our mind, this is a useful method, especially pinnacle rearrangement is useful method for making a tertiary alkyl ketone, because this is protonated and we get a system like this, in which we have tertiary ketone, tertiary alkyl ketone. So here this example was used for ring expansion. So whenever we need a ring expansion, we will keep the application of diazoalkanes in our mind. And as far as when we want to get tertiary alkyl ketone, so we should have pinnacle rearrangement in our mind. Next we are focusing on epoxide rearrangement. By keeping the system in mind, which we introduced at the start of this lecture. So this molecule can be obtained with the application of epoxide rearrangement. Epoxide rearrangement. So let's check how we can get the molecule. We have a cyclohexanone and we subjected it to a sulfur elite. Which we have talked earlier for transforming ketone into a three-membering system. And this three-membering system is quite reactive, that can be opened even by a weak Lewis acid such as LiBr or lithium bromide or magnesium bromide. For getting the molecule, usually when we have a system like this, it is protonated for generating a stable carbocation. This bond will break like this, and we will hydroxyl group and carbocation over here. These are two hydrogen. One will shift right over here, and we will get the system like what we have achieved right over here. So this is one method by using the application of sulfur elite. Next, we can use diazoacetic ester I, chloroacetic ester, and base. For example, we can get the system which is hydrolyzed basic condition. We're getting carboxyl group. This is heated, that undergoes a ring opening reaction, and we get system like here we have a carbocation after ring opening, and this rearrangement takes place, which is decarboxylation. And we get a system like and this system is ultimately rearranged like for getting the sorting material. So this is how we can obtain the target molecule. Let's consider another system which we have introduced at the start. So we subject it into retrosynthetic analysis. We have this extra methylene group. By applying this application route, so we can easily like this, because the synthesis will be simple and it involves which is a 3-member epoxide ring, and then we subject it into basic condition, and then protonation plus heat, we will get the target material. So one last example which we have introduced at the start, we should focus on that so that we could finalize our topic with respect to rearrangement in organic synthesis. Here, this was the example. So this example involves Favorsky rearrangement. Before we understand Favorsky rearrangement, we cannot subject this molecule into retrosynthetic analysis. So let's first focus on Favorsky rearrangement. which involve the conversion of alpha haloketone to an unstable cyclopropanone that decompose to ester, where the stable carbanion act as a leaving group. So we usually convert alpha haloketone into ester. In Favorsky rearrangement, for example, we have system like this, which is alpha chloroketone subjected to basic condition, we get an analyte like this, where the double bond will attack while chlorine group will be expelled, and this will shift right over here, and we will get a system like this, which is again treated with the base for getting is the epoxide. So this will shift right over here, and it will abstract proton from the solvent, and we will obtain a molecule like which is ester. So this is all about Favorsky rearrangement. Now let's focus on the example which we have introduced at the start of our session, and we are subjecting it into retrosynthetic analysis. So let me perform a Favorsky rearrangement, and I will get alpha bromoketone. I will break the CBr bond, this, and I will get species like this, which is again subjected to functional group interconversion, oxidation, and Grignard reagent, so that we could get the starting material. So this is the retrosynthetic analysis of the target molecule. Here we have a synthesis so that we could understand what has happened. First we will treat the alkyl halide with magnesium, the aldehyde and chromic oxide for oxidation. I will get the species like this, which will be treated with the methoxide, and I will obtain an unstable species. That again, when treated with methoxide, will generate a target material. So this is how we can get to the starting material. So this is all about rearrangement. We should have to conclude, we should have Ordinance straight reaction in mind beside ring expansion example. We could have epoxide rearrangement, pinnacle rearrangement, and Favorsky rearrangement. So all these should be kept in mind before subjecting unusual organic molecule to retrosynthetic analysis. Thank you for watching the session.